Good day, good people. Rob here from Tasman Energy, Down Under in Tasmania, Australia. And today we're going to start putting in the solar array. This is part 2 of our installation series on putting in a simple standalone solar power system. In part 1 we looked at putting in the battery bank here. Today we're going to start putting in the solar array that will charge this battery bank. The solar panels I've chosen are actually grid feed solar panels designed for putting power into the electrical grid, but they're quite well suited to battery charging as well. The ones I've got here are Jinko Solar, a common Chinese-made, reasonable quality solar panel, and they're 275 watts each. I'm going to put in 6 of them, which will give me a 1650 watt or about a 1.6 kilowatt solar array, which will be plenty big enough for my needs in this shed. These panels come, and all panels that you buy will come with a thing called a data placard on the back. We'll just have a quick look at what this data placard says. It tells me something very useful. It tells me the dimensions for the panels to save me measuring them, and it will average out if there's any slight variation in them when I come to mounting them. And it also tells me the maximum power voltage. The maximum power voltage is relevant because we need a voltage suitable for charging this battery bank. In the case of these panels, the maximum power voltage is delivered at 32 volts. 32 volts is not enough for a 48 volt system, but if I put 2 of these in series, I'll have 64 volts, which is pretty much ideal to charge a 48 volt battery bank. The solar array needs to have a higher voltage than the battery bank in order for the current to flow from the panels to the batteries. 64 volts is a little bit high for a 48 volt battery bank. Somewhere about probably 58 volts would be more ideal. And if I bought dedicated solar panels designed for charging batteries, that's what I would end up with. But 64 volts will be fine. They'll connect straight to the batteries via a solar regulator, and I think it'll work quite efficiently. If you find some very reasonably priced panels that have a different voltage than this, say 45 volts or something like that, 45 volts is too high for a 24 volt system, and 2 in series would be 90 volts, too high for a 48 volt system. You can still use them, but instead of using a conventional regulator, you would use a thing called a maximum power point tracking regulator, which will take a different solar panel voltage and convert it to a charging current for batteries. I'm keeping it simple today. I'm just using a conventional solar regulator, and 64 volts will actually work very, very well indeed. To mount these panels on the roof, I want them to face north, or approximately north, or if you're in the northern hemisphere, you want them to face south, and I want them at a tilt angle. So I'll just talk about the direction first. North here where I am, I can look at a magnetic compass, and there's a magnetic variation of 13 degrees between where the compass points and where north is. The magnetic variation is east, so I'll have to be to the right of where the magnetic compass points by about 14 or 15 degrees. But that said, this building here is aligned approximately north-south, and I can't even be bothered getting a compass out to find out whether it's 10 or 15 degrees off north or off south, or even that. It doesn't really matter. I'm going to line these up perfectly along the roof battens that hold the tin on the roof, and if they face slightly more to the east, I will get more power in the morning than in the afternoon. If they face slightly more to the west, I'll get more power in the afternoon than in the morning. The angle isn't as critical as what most people think. Up to 15 or 20 degrees either side of true north or south, if you're in the northern hemisphere, will work very, very well. It is probably cheaper to buy additional panels. It's probably more economical to buy additional panels than it is to mess around up on the roof and angle the array across the roof battens. To put these panels on the roof, they need to be at a tilt angle as well. The tilt angle is generally set to the latitude of your location. Here we're 42 degrees south, so I'm going to put them at about 42 degrees. 45 degrees is fine. If I wanted to get more power in winter, I'd stand them up a bit further to say 60 degrees. And if I wanted to get more power in summer, I would drop them down to say about 35 degrees. But 40-45 degrees, for all intents and purposes, will work very, very well. So I'm going to put them facing approximately north mounted along the roof purlins or battens, and I'm going to tilt them at about 45 degrees and accurately measuring the magnetic direction, or the direction north, or accurately measuring the tilt angle is not really necessary. To mount them on the roof, I'm going to use aluminium that I bought from the aluminium shop. I could be using a dedicated solar system mount, and in fact that would make the panel mounting a lot quicker and a bit easier. But this aluminium was readily available from a local supplier in the city near me, and it's just stock aluminium sold for a variety of purposes. For the struts that hold the array up, I've chosen 40 by 40 by 3 mil, and for the rail that holds the panels on, I've chosen 40 by 40 by 3 mil, but I've chosen a channel section rather than an angle section. The angle sections will be cut to length. I'll have 4 lengths, not quite as long as the panel. You can see that the panels actually comes with mounting holes in it, but I'm not going to use those. I need the strut about 80–90% the length of the panel, so I'll easily get 4 out of a 6.5 metre length. Those 4 lengths I'm going to bring up from these angles, these brackets, which I'm going to fit to the roof battens. I'm going to bring them up at about my 45-degree angle, and then I'm going to take another piece of angle and I'm going to go down to a roof batten that's further back up the roof, and I'm going to put another bracket, and that's going to form a triangle made out of 40mm angled aluminium. It'll come up off the roof at 45 degrees. The panels will mount on rails on the front. It'll go back down to the roof to give it strength and to block it up at that angle. And the roof will form the third section of the triangle. On these 4 triangles I'm going to build with this aluminium. I'm going to put 2 horizontal lengths of the channel, and it's to this channel that I'm going to mount the panels. These angle brackets are from a solar system mount, left over from a job I've done in the past, but they could equally be pieces of angled aluminium just cut from stock, or even pieces of angled steel. They're just to securely put the mounting triangles on the roof. To mount the panels to the rail, I'm going to use solar panel clamps. These are also left over from a job. These are going to clamp the panel to this rail, and I'm going to precision drill along this rail holes at the panel width plus half the clamp width, and I'm going to put the panels on the rails and I'm going to clamp them to the rails. If you don't have these mounts, you can put the panels on the rails, and instead of precision drilling them for the clamps, you could precision drill them to line up with the holes in the panels and bolt them on with a bolt. Or you could use a material other than channel, and you could actually pop rivet the panels on. I've riveted panels on 20, 22, 23 years ago. The panels are starting to fail, the rivets are holding them absolutely fine. Before we go ahead and do the precision drilling, just a quick word about the solar panels here. The front side of the solar panel is a bit like the windshield in your car. It's very, very tough, it's strong, it's scratch resistant, it's hail proof. The back of the solar panel is actually quite fragile. The back of the solar panel's got very, very thin silicon cells glued to the glass, and they're just covered with a layer of plastic sprayed on. So if I'm drilling the back of these to, say, put a pop rivet in, and the drill breaks through and contacts the back of the panel, I will damage the panel and it won't be repairable. So you've got to be very careful with the back of the panels. And if you're going to drill through here, I would always put something through behind where I was drilling to catch the drill and prevent the drill bit from contacting the panel. I'm going to go ahead now and set up so we can precision drill the channel. And the precision drilling technique is exactly the same. If I was drilling for these bolt holes, I'd use exactly the same technique as if I was drilling for these mounting clamps, which I'm going to use. So I'll go ahead and set up the drill now, and I'll show you how to precision drill a mounting rail to put these panels on the roof. Alright, these are the rails I've got to put my solar panels on. As I said before, they're 40 by 40 by 3mm. They need precision drilling at the spacing for the solar panels. To precision drill them, I've made a template up with a piece of steel. It's got the holes at the exact spacing, and I'm going to clamp that to the rail using a pair of vice grips. These vice grips are very, very handy things. They'll hold solar panels on the roof, on the rails while you drill or bolt them or put them in position. They'll hold all your array frame together while you bolt it. Very, very handy device. I've got half a dozen odd pairs of them. Right hand when you're solar panel fitting. I'm going to clamp my template to the rail using the vice grips. And I'm going to precision drill it just using a cheapo Ryobi drill press. Here we go. That's the first two holes drilled at the precise distance for the solar panels. Now I'll simply get my template and I'll slide it along the steel and I'll locate this hole with a drill bit, another drill bit, there it is there, and I'm ready to drill a hole, clamp it back on again. There we go. And that's how I precisely drill the aluminium rails to take the solar panels. Quite a simple technique and very accurate, provided that my template is accurate. Right, here we are up on the roof. I'm just giving you a bit of a pan. I've got the 4 triangles up as described, and they're bolted to the roof with little angle brackets going down through the roof battens. There's a look at the angle brackets. I've got an upright. I've got my front slope going down to another angle bracket on the roof. And on the front faces of these uprights, I'm going to put the long rails which will take the panels. So I've got 4 of these in. You can see them down the roof there. And they're a little bit narrower than the width of the array. The solar panels will hang off the ends a little bit. And I'm going to go ahead and I'm going to clamp to these things using my vice grips, the rails that hold the panels on. Okay, that's just about got the solar panel array mount finished. The triangles are bolted firmly to the roof via the angle brackets, and the rails have been put on across the top and the bottom of the triangles. What I've done is put the top rail on super straight, clamped it in position with vice grips, and then drilled it from underneath and bolted it. And I've put the bottom rail on absolutely parallel to the top rail. I've gripped it in place with vice grips. I've measured the diagonals to make sure it's perfectly square to hold the solar panels, adjusted that as necessary and got it perfectly square with the top rail and parallel. And then I've gone through and I've bolted the bottom rail on, and I've gone through and I've done up all the bolts tight, and it's ready to put the panels on. Right, here we are back up on the roof, and I've started putting the panels along my solar mounting rails. As I said before, they're just clamped to the mounting rails using these little clamps, and I'll give you a look. There's a little clamp, and it's just clamping down, holding the panel onto the rail below it. Another clamp here, and at the end the clamps are slightly different. They're an L bracket clamp. And these panels have gone up remarkably quickly. I have got a friend here who's a little bit camera shy, but he's been helping me lift the panels into position, and 3 of them have gone up in about 5 minutes. Just come back here. And there's what they look like. There's 3 panels nice and securely mounted on the roof. Here's how the clamps go on. I've got to hold my camera and give you a demo, but the bolt comes up through this hole here. And then I put the clamp on top of that, and that's got a clamp just sitting there loose. So I'll slide the panel up to the clamp, and I'll go over like that, and I'll tighten it up with a spanner, and that'll clamp the next panel down. These panels these clamps hold the panels in place absolutely beautifully just at one end while the next panels are lined up. Well, that's the completion of the solar array. Here I've got 6 solar modules up, 275 watts each, mounted to a homemade solar panel mount. Just quickly run through what it is. At the bottom of the array I've put an L bracket into the roof here, and from this L bracket I've taken 40 by 40 by 4 mil angle aluminium up at approximately 45 degrees of an angle, bolted it at the top, and I've taken it back down to another L bracket mounted on another roof batten. I've put up 4 of these triangles along the back of the array, and to the top of them I've put in 40 by 40 by 4 mil aluminium channel. I've faced the channel downhill so it doesn't catch water, and it can also serve as a place to safely tuck the solar feed cables when I come to connect it up. I've precision drilled this rail using a template which I showed you earlier in the video, and through the holes that I've drilled in this array I've come up with these little brackets. There's a little L bracket on the end here. It clamps the panel on with a bolt. I passed it up through the channel, through the clamp, and did it up, and this clamps the panels very tightly to the support rail. A little bit quicker using the clamps than drilling holes and bolting the panels in, but bolting them is just as good. All these fittings are stainless steel. They don't seem to react with the aluminium. Array frames that I've built like this in the past have withstood the test of time and are actually outliving the solar panels that are attached to them. Quality aluminium from the aluminium shop down the road, and there's the completed array frame. There's wires hanging out with a positive and negative wire for each panel, and in the next installation series I'll detail how to connect them up and get the solar feed system happening.